This is video number 177. In this video, I will explain topic dinitrogen. Nitrogen exits as a diatomic gas in the elemental state. So we have to say dinitrogen. So that's reason we have to say dinitrogen because nitrogen exits as a diatomic gas in elemental state. Preparation. There are three methods to prepare dinitrogen. First method used in the laboratory. So laboratory method, NH4Cl, NaNO. Ammonium chloride react with the sodium nitrate. NH4Cl react with the NaNO, sodium nitrate. Heat. So convert it to the nitrogen gas, NaCl and then H2. Okay. So ammonium chloride react with the sodium nitrite and heat. So nitrogen gas are formed. Okay. Then second preparation method is ammonium dichromate, NH4 twice Cr2O7. Whenever heat, so it is also form nitrogen gas and chromium oxide. So ammonium dichromate easily prepare nitrogen gas only for heating. Okay. Then third is barium agile, Ba(N3)2. Ba(N3)2. Barium agile when decomposed, so it is converted to the barium and nitrogen gas. So there are three methods to prepare dinitrogen. First is ammonium chloride react with the sodium nitrite and heat, so converted to the nitrogen gas. Then ammonium dichromate when heat, so then converted to the nitrogen. And then barium agile also decomposed, so converted to the barium and nitrogen gas. Then after properties. So we will discuss about properties. Nitrogen gas colorless, odorless, tasteless and non-toxic gas. Okay, and you already know about nitrogen available in the atmosphere 78% by volume. Okay, maximum amount of the nitrogen. So it is a non-toxic gas. Then it has two stable isotopes. First one is 14N and second one is 15N. So two stable isotopes, 14N and 15N. Third one is low solubility in water. Whenever it dissolves in water, so low soluble. So low solubility in water, its freezing point and its boiling point also low. Then because low solubility, so it is less temperature required. So boiling point also low. Then inert at room temperature. You already know about 78% maximum amount of the nitrogen present in the atmosphere. So it is a non-reactive. Okay. So it is a inert at room temperature and high bond enthalpy. Reason why inert? Because high bond enthalpy of the nitrogen triple bond nitrogen. Then nitrogen react with the metal like metal, magnesium, lithium. So whenever react with the metal, so it is formed the nitrite. Like example, magnesium. Nitrogen react with the magnesium and then heat. So it is formed Mg3and2. Magnesium nitride. Magnesium react with the nitrogen and heat. So Mg3and2. Magnesium nitride are formed. Then react with the hydrogen. React with the hydrogen. Nitrogen react with the hydrogen and temperature 773 Kelvin. So it is converted into the ammonia gas and it is this process known as Haber process. Haber process, in this Haber process, we have to prepare ammonia by nitrogen and hydrogen. So nitrogen and hydrogen react and then formation ammonia gas. Then nitrogen react with the oxygen and formation oxide. So see, heat and NO, nitric oxide gas are formed. Okay, so these are physical and chemical properties. Then uses of the dinitrogen. Nitrogen is used in the manufacture of the ammonia and other nitrogen compound. Then it is produced to the atmosphere in industries. Then it is used in the cryosurgery. Okay. Then liquid nitrogen, especially liquid nitrogen used as a refrigerant. Refrigerant that is used to preserve any food stuff and okay. So liquid nitrogen used as a refrigerant. So these are commonly uses of nitrogen. Next topic is compounds of the nitrogen. So first we discuss about compound ammonia. Okay, compounds of the nitrogen. First compound discuss ammonia, NH3. So first we have to see preparation. So natural process is by decay of nitrogen organic matter. Decay of the nitrogen organic matter, nitrogenous organic matter like urea, NH2CO, NH2. NH2CO, NH2, this is urea, it is a nitrogenous organic matter. So by decay of the nitrogenous organic matter, first in the presence of the water, urea convert into the ammonium carbonate, see, NH4 hold twice CO3. Then after it is convert ammonia gas, CO2 gas and then water. So this is the natural process by the decay of the nitrogenous organic matter. Urea convert into the ammonium carbonate and then after convert into the ammonia. Next in laboratory method. Laboratory method in lab, ammonium chloride react with the calcium hydroxide. Okay, and heat. So convert into the calcium chloride, ammonia and then water. So ammonium chloride react with the calcium hydroxide, slag line. So heating. So ammonia easily formed. But on a large scale, Haber process used. Haber process, nitrogen gas react with the hydrogen gas and convert into the ammonia gas. Okay, and this is the exothermic reaction, and this reaction explained according to the Le-Chatelier principle. And see, this is the forward reaction and backward reaction. Okay, so in the forward reaction, nitrogen gas react with the hydrogen gas, direct combination, nitrogen and hydrogen gas. So ammonia gas are formed, and exothermic reaction. So enthalpy 46.1 kJ per mole, and this process is Haber process. I will be discuss flow chart. See, hydrogen gas and nitrogen gas. Hydrogen gas, nitrogen gas going to this tube, and by applying the compressor, okay, both gases are compressed and going to this chamber, and this chamber catalyst also present, and temperature we have to apply 700 Kelvin temperature. Catalyst iron oxide, aluminum oxide and potassium oxide. In the presence of the catalyst and temperature, nitrogen and hydrogen gas going to this and then convert into the ammonia gas. Then after ammonia gas, this way ammonia gas going to this tube, and this is the condenser, and in condenser ammonia gas convert into the liquid ammonia. So condense into the liquid. So this ammonia condense into the liquid ammonia, and backward reaction when nitrogen and hydrogen are reacting. So by the pump, nitrogen and hydrogen going to this gas and then again compress and then go out. Okay, but this is the flow chart. First hydrogen and nitrogen gas going to the compressor, then after catalyst chamber, and then formation ammonia, and ammonia again going to the condenser and condense into the liquid ammonia. So this is the flow chart of the liquid ammonia. Okay, and Haber process. On a large scale we have to use Haber process. So direct combination of the nitrogen and then hydrogen, and it is formed ammonia gas. But this reaction is exothermic reaction. Okay, so on a large scale we have to use this process. So there are commonly three processes: natural method, laboratory method and then industrial method. So there are three methods: natural, laboratory and then industrial method. So in an industry on a large scale we have to use Haber process. So this is the flow chart. Next is properties of the ammonia. First we discuss physical properties of the ammonia: colorless gas, pungent odor. Freezing point 198.4 Kelvin and boiling point 239.7 Kelvin. Its higher melting point and boiling point. Reason: because in ammonia hydrogen, so So due to the hydrogen bonding, its melting point and boiling point is higher. Then soluble in water. Ammonia gas react with the water. So it is convert ammonium ion and hydroxide ion. So ionized in the water. So it is soluble in water. So soluble in water. So ammonium ion and hydroxide ion obtained. Then react with the acid. Ammonia when react with the acid like HCl. Okay, ammonia react with the HCl, hydrochloric acid. So ammonia react with the hydrochloric acid. So to formation ammonium chloride, NH4Cl. Okay, ammonia react with the HCl, hydrochloric acid. So convert into the ammonium chloride. Then react with the metal ion. Ammonia react with the metal ion like copper plus 2 ion, Ag plus ion. So react with the metal ion so to form a complex way. Like here you see ammonia. Nitrogen has a lone pair, so it behaves as a Lewis base because it donates to the lone pair to other metal ion. So ammonia react with the AgCl, silver chloride. Silver chloride has a white purity. So ammonia react with the AgCl, so it is formed complex AgNH3 whole twice Cl. So this complex are formed and this complex is colorless. Then after ammonia react with the copper plus 2 ion. Any compound of the copper. So copper is like sulfate. So it is a blue color. So ammonia react with the copper plus 2 ion. So it is also formed complex CuNH3 whole 4 2 plus and it is a deep blue color. Okay. So ammonia react with the blue ion copper plus 2. So it is formed this type of the complex CuNH3 whole 4 2 plus deep blue color of this complex. Okay. So these are properties of the ammonia. Then after structure of the ammonia. Ammonia in nitrogen 15 group of the element. So 5 electron in outer shell. So 3, 1, 2 and 3. 3 electron share with the hydrogen and 2 form bond. So 3 bond pair and 2 electron as a 1 lone pair. Okay, so total 5 electron complete. 1, 2, 3, 4, 5. 5 electron of the nitrogen complete. Okay, so 3, 1, 2, 3 bond pair and 1 lone pair. So between the angle hydrogen 107.8 degree and bond length between the nitrogen and hydrogen 101.7 picometer. So this is the structure of the 1, 2, 3 trigonal form and noted as a pyramidal. So its structure name is trigonal pyramidal. Okay, and 3 bond pair and 1 lone pair. So 3 plus 1, 4. So 1s and 3p, sp3. Okay, so nitrogen atom sp3 hybridization and trigonal pyramidal structure and 3 bond pair and 1 lone pair. So this is the structure of the ammonia, trigonal pyramidal. Okay, got it. Then uses of the ammonia. Especially in ammonia, liquid ammonia especially used. Liquid ammonia used as a refrigerant. Okay, then ammonia used to the manufacture especially strong acid, nitric acid. Okay, HNO3. So ammonia used to the manufacture HNO3 nitric acid. Then used to the produce nitrogenous fertilizers. Which fertilizers nitrogenous? Like ammonium nitrate, ammonium sulfate. Okay, so these are nitrogenous fertilizers by using of the ammonia it produces. Okay, so these are common uses of the ammonia. That is clear?
Then next topic is oxides of the nitrogen. Oxides of the nitrogen, it is explained by the table. So nitrogen forms a number of the oxide with the different oxidation state. Okay, so these are compounds like first one is dinitrogen monoxide. This is the first compound. Second, nitrogen monoxide. Third, dinitrogen trioxide. Fourth, dinitrogen dioxide. And fifth, dinitrogen tetroxide. And sixth, dinitrogen pentaoxide. So see, dinitrogen monoxide N2O, nitrogen monoxide NO, and dinitrogen trioxide N2O3, nitrogen dioxide NO2, and dinitrogen tetraoxide N2O4, and dinitrogen pentaoxide N2O5. So its oxidation state of the nitrogen. Oxygen you see -2 and nitrogen we have to find. So 2x minus 2 is equal to 0. So x is equal to plus 1. So we have to find this way. NO oxidation state of the nitrogen +2. In N2O3 nitrogen oxidation state +3. NO2 nitrogen oxidation state +4. In N2O4 oxidation state of the nitrogen +4, and in N2O5 oxidation state of the nitrogen +5. Then we have to see preparation. N2O nitrogen monoxide, dinitrogen monoxide prepared by the ammonium nitrate NH4NO3, okay, and heat, so convert into the N2O and H2O, but it is a colorless gas and then neutral. Then NO nitrogen monoxide gas prepared by the sodium nitrite NaNO2 FeSO4 H2SO4. When react, then iron sulfate, sodium hydrogen sulfate, water and nitrogen monoxide are formed. So nitrogen monoxide gas, colorless gas, neutral and paramagnetic. Then dinitrogen trioxide. Dinitrogen trioxide formation by NO, dinitrogen monoxide, and N2O4, dinitrogen tetraoxide. When heat at 250 Kelvin temperature, so it is converted into the dinitrogen trioxide. But this is the blue solid and then acidic. Okay. Then lead nitrate. Heat at 673 Kelvin temperature. So nitrogen dioxide NO2 gas are formed and PbO and then O2. So nitrogen dioxide gas, brown gas, reactive and paramagnetic and then acidic. Brown gas, reactive, paramagnetic and then acidic. Then next one is N2O4, dinitrogen tetraoxide. Whenever NO2, nitrogen dioxide cooling, then convert into the N2O4, but when N2O4 heat, so nitrogen dioxide form. But this is the nitrogen tetraoxide, colorless and exit both in solid and liquid. Okay, but with NO2 in equilibrium and acidic in nature. Then N2O5, dinitrogen pentaoxide. It is a byproduct. Metaphosphoric acid also form HPO3 when nitric acid react with the phosphorus pentaoxide P2O5. So N2O5 and HPO3 metaphosphoric acid are formed. But N2O5 dinitrogen pentaoxide, unstable gas. In the solid state, exit at cation and anion, NO2 plus and NO3 minus, colorless and then acidic. So these are properties of the each oxide of the nitrogen. First one is dinitrogen monoxide, second one nitrogen monoxide, third one dinitrogen trioxide, fourth one nitrogen dioxide, and fifth is dinitrogen tetraoxide, and sixth dinitrogen pentaoxide. So these are oxide of the nitrogen. Okay. Next compound of the nitrogen, nitric acid, HNO3. Nitrogen forms 3 oxo acid. First one is hyponitrous acid, H2N2O2, and nitrous acid, HNO2, and third HNO3, nitric acid. But nitric acid is the most important. Okay, so first preparation is laboratory sodium nitrite heating with the sulfuric acid. So sodium bisulfite and nitric acid are formed. So in laboratory this method are used. So it can prepare by the heating NaNO3 with concentrated H2SO4 in a glass retort and condense the vapor of the HNO3. Then on a large scale, that is means in industry, which process are used? Ostwald process. In Ostwald process, catalytic oxidation of the ammonia by atmospheric oxygen. Okay, platinum and rhodium gauze catalysts are used, and then 500 Kelvin temperature, 9 bar pressure. So NO gas are formed. Okay, and this NO gas after combined with the oxygen, so giving NO2 gas, and this NO2 gas react with the water, so it is dissolved in water and to give HNO3. So there are 3 steps. First one, ammonia react with the atmospheric oxygen, so nitrogen monoxide gas form. Second, nitrogen monoxide again combined with the oxygen, so giving nitrogen dioxide. And third step, nitrogen dioxide react with the dissolved in water, so to give HNO3. Okay, but NO gas, this NO gas is recycled and aqueous HNO3 is concentrated by distillation up to approximately 68%. But concentration to the 98% achieved by the dehydration with concentrate H2SO4. So we have to use after concentrate H2SO4 and dehydrate. So HNO3 98% concentrate obtained. Okay. Then properties. HNO3 nitric acid colorless liquid, freezing point 231.4 Kelvin, boiling point 355.6 Kelvin, and in its pure form and becomes yellow due to the presence of the nitrogen dioxide, because present as an impurity and make it impure. But laboratory grade nitric acid contain approximately 68% of the HNO3 by mass and a specific gravity of 1.504. Then property, nitric acid react with the water and formation hydronium ion H3O plus and NO3 minus. Then fourth, nitric acid is a very strong oxidizing agent and it is react with the copper. So it is form copper nitrate, like copper react with the HNO3. Okay, because strong oxidizing agent and it attack on many metal, only for exception noble gas like gold and platinum. So nitric acid react with the copper, so formation copper nitrate. Okay, so this is the product of the oxidation depend on the concentration of the acid, temperature and nature of the materials. Okay, here you see, here 8 HNO3 used, so copper nitrate 3 molecule are formed. Here single copper used, so single copper nitrate are formed. Okay, so react with the nitric acid like zinc, nitric acid react with the zinc and then iodine, okay, carbon, sulfur, phosphorus, so different reactant, okay, nitric acid react and then formation of the new product. Okay, noble metal like gold, platinum do not react with the nitric acid. Okay, so they dissolve in the aqua regia forming respective chloride like HNO3 react with the HCl. So both are acid, so it is formed nitrosyl chloride and then water and then HCl. So HNO3 and then HCl 1:3, nitric acid 1 and HCl amount 3. So 1:3 whenever mix up, so it is formed aqua regia. We have to say aqua regia. So noble metals like gold and platinum do not react with the nitric acid and they dissolve in nitric acid in aqua regia. Okay, gold and platinum dissolved in the aqua regia and aqua regia formed by 1:3. 1 HNO3 1 and HCl 3 1:3. Whenever aqua regia form, so nitrosyl chloride and water and Cl, and then gold and platinum react with the chlorine Cl. Okay, and aurum react with the chlorine, so AuCl3 form, and then platinum react with the chlorine, so PtCl4 form. Nitric acid structure here you see, NHNO3. Okay, 3 oxygen, 1 hydrogen. Nitrogen and oxygen between bond length 121 picometer and oxygen nitrogen bond angle 130 degree. Nitrogen and oxygen center oxygen 140.6 picometer bond length and nitrogen oxygen hydrogen bond angle 102 degree and oxygen hydrogen bond length 96 picometer. So this is the structure as a planar way. Okay, but this is a structure present in the gaseous state. So HNO3 exit is a planar state structure, planar molecule in a gaseous state. So it is used in the manufacture of the ammonium nitrate for fertilizers, and then nitric acid used as oxidizer in rocket fuels, and then pickling of the stainless steels, etching of the metals, and used in the preparation of the nitroglycerin, trinitrotoluene and other organic nitro compounds. So simple concept is nitric acid, it is a strong oxidizing compound, most important in terms of the laboratory and industrial application. Okay, so it is used as an oxidizer in rocket fuels, okay, and especially used in the preparation of the organic nitro compounds. Okay, next topic is phosphorus. So I will be explain next video.